All right, 9-1, we start significance test, the basics. And so we've talked about a lot of the stuff in class today, and then I'm going to go a little bit more in depth here on the things. So we're going to state correct hypothesis for a statistical significance test about a population proportion or mean. So we're going to learn how to state them correctly. We're going to interpret p-values in context, and interpret a type 1 error and a type 2 error in context, and give the consequences of each. And describe the relationship between the significance level of a test and the probability of a type 2 error and the power of a test. This we're going to do more in class tomorrow when we do the Inspire activity together. So let's get going here. Oh, I guess I needed to say start from current slide. There we go. There we go. That might look better to you all. Okay, confidence intervals are one of the two most common ways of statistical inference. So we've already done those. The other one that we're going to learn about in this section is called significance test. That's the other most common. So like I said, we're going to keep doing confidence intervals and significance tests the rest of the school year. A significance test is a formal procedure for comparing observed data with a claim. So what we get when we actually take our sample to a claim, and that's called the hypothesis, whose truth we want to assess. The claim is a statement about a parameter. So remember, a parameter here is going to be, parameter deals with population, so that should be what registers in your brain when you read parameter. So a statement about the population, like the population proportion P or the mean mu. So know that your hypothesis is always going to be written with a P or a mu in it. And so you're going to use those symbols because we're representing the population. We express the results of a significance test in terms of probability that measure how well the data and the claim agree. All right, so in this chapter we'll learn about the underlying logic of statistical tests, how to perform the tests about the population proportion and the means, and how tests are connected to confidence intervals, so how they relate, and I talked about that a little bit in class. Statistical tests deal with the claims about a population. Remember, they're about a population. Tests ask if the sample data, so then we actually take data, which is a sample, if it gives good evidence against the claim, okay? A test might say, if we took many random samples and the claim were true, we would rarely get a result like this. To get numerical measures of how strong the sample evidence is, replace the vague term rarely by a probability, okay? So we would, this percent of the time, get results like this. So we're going to place this word rarely with the actual probability. So we kind of looked at a simulation of this today. It says, suppose a basketball player claims 80% free throw shooter. To test the claim, we have him attempt 50 free throws. He makes 32 of them. His sample proportion is made up of made his shots 32 out of 50, which is a 64%. What can we conclude based on the claim on the sample data? So we want to know, is this far enough away from this? So we can use software to simulate 400 sets of 50 shots. So they're going to let him take 50 shots 400 different times, and then they're going to plot it, assuming the player is really an 80% shooter. We can say how strong the evidence against the player's claim is by giving the probability that he would make as few as 32 out of 50 free throws as he really makes 80 in the long run. So here is what it should be. This is the distribution. In 400 sets of 50 shots, there are really only 3 times when the shooter made as few of the observed 0.64 or less. So what they're doing is they're saying, let me move this. All right, so what we're looking at here is this. This is where he actually should fall. If this is true, okay, this is given that it's true. This is true, this should be the distribution. That being the case, he only got a point, and our person got a 0.64, or p-hat. So you could have only got a 0.64 this many times, given that this is true. So if this is true, I could have only gotten this in my sample 3 out of 400 times. 3 out of 400 times. Okay, could I get this p-hat of 0.64 given that this is actually true? Well, that comes out to be not very likely. So if I took 3 divided by 400, it's going to be like 0.0 something, let's see, 30 divided .07 something maybe. I don't know. I don't have it in my. Sorry, I don't have it here. They do though. Here we go. The observed statistic is so unlikely if the actual parameter value is 80 that it gives convincing evidence that the player's claim is not true. 3 out of 400. Okay, so it's not, the probability of that happening is only 3 out of 400 times. Could it actually, this or more extreme, so we're going out, more extreme could occur given that this is true.